If you're starting your data science journey or if you want to level up your skills in data science, this video has everything you need in one place. No more jump between multiple videos to learn multiple topics or to know what to, at least you should know what to learn to become a data scientist. That is the most critical, right? Before you start learning it. So make sure you are still the end. So here are the topics what we'll cover today. First, we'll cover who is a data scientist. Then we'll see what data scientists actually do in their day-to-day life. Then we'll see the data science project lifecycle overview, how a data science project lifecycle works, from where it starts, how it ends, and how it proceeds. Then we'll cover the main topic, data science roadmap. Okay, so let's start with the basics. So first of all, we'll see who exactly is a data scientist. So a data scientist is a professional who use any machine learning algorithm or deep learning algorithm or any programming language to extract any insights from data and solve any real world problems, whether it's predicting any customer behavior, predicting disease, optimizing supply chains, or detecting any fraud. Data scientists help organizations to make those data driven choices. They help them to know where to go and how to go. In short, they don't just analyze data, they tell stories with it. So let's have a quick overview what they do on a day-to-day life. Mostly a big chunk of time is spent on data wrangling and data cleaning. Mostly whatever the data they will get from their organization, those are it will be raw form and converting them into a usable form. Next, they will perform some exploratory analysis to understand the trend and visualize the data. Then they will build some machine learning models which will help in doing some predictions, be it using churning of employees or forecasting sales or predicting diseases. They will do building some models. Next, they will create dashboards and reports using tools like Power BI or Tableau kind of thing, which will help to share their insights to the stakeholders. They mostly work closely with the business team, product managers, and AI engineers to make sure that their models are actionable and aligned with the real needs. And of course, they stay updated, constantly learning new tools and libraries because AI world is very evolving day by day. Every day we are getting some new update, so it's a very fast moving field. So you have to cope up with the new invention coming up. It's not just about coding or models, it's about solving real problems using data. So now let's look at the data science project lifecycle, a step-by-step process which used in most of the data science projects. There are different stages in the data science project lifecycle. First of all is the problem definition. So before going to data or before building any model or before understanding also the data, first of all you have to understand what problem you are trying to solve it. What is that real world problem? Whether it's like predicting any disease, which disease we are going to predict, how those disease occurs. Apart from the data, what exactly the domain tells about that problem. For example, customer churns, right? Why are customers churns rate increasing? So this is a I can say one line summary of the problem definition. Next, once you understand what the problem is or what the real world problem you are trying to solve, next you will be going to data collection. Here you will first gather the data. So be it collecting from the customers or collecting data from the databases or APIs, or you're doing web scraping, or sometimes a CSV file or Excel sheet. So there are multiple ways to get the data or collect the data which on which you will going to work. So here the main goal is to find the relevant quality data to you work with. Next is feature engineering, or what you say as data cleaning and pre-processing. So here what you do, once you got the real-time data, because those are raw data, so those data will be very messy. So there you need to do a lot of cleaning and stopping. For example, fixing missing values, or there are duplicates, removing duplicates, or transform any variables. So this is the most critical step in the whole data science project lifecycle, where it takes up to almost half of the time, or 50 to 60% time of the entire project time. Because unless until you don't have a clean, pre-processed, perfect data, whatever model you build, that will never going to work in a good way. So data clearing and pre-processing is the most important step in the whole data science project life cycle. Okay, so once this has been done, so these are then you will try to do the EDA means basically exploratory data analysis, where you are trying to explore the data, you trying to understand the data, what is there any pattern in the data, what are the statistical summary in the data, or you having any anomalies. So basically you try to build any kind of plots, different kinds of charts, uh, different kind of statistical concept to try to apply, so that you will get uh, a wide idea on what the data is, and is there anything you can extract from the data on a summary basis. So now you clean the data, you understood the data. Next is you have to do the feature selection. What happen in some project is whenever you have a lots of data, wherever you have thousands of columns, because that is very common in the real problem. You will never have 5 10 columns, you will minimum hundreds or thousands of columns will be there. But any machine learning model you build on thousands of columns, it will never work, because it's a very huge number of columns to uh, build any model on that. So here you will try to optimize the data basically, so that you will try to reduce some of the columns which are not necessary. There are, we will see all those ways how to do feature selection, and all those steps. So next, once your data now, till this step data is ready, so next you are going to build the model building. So in model building you have to choose, there will be n number of algorithms in machine learning, deep learning. So you have to choose, initially you have to start with few sets of algorithm, and then you have to build the model. Then you have to simultaneously you have to evaluate the model, because you once you build the model, you don't know how that model is performing, right? So basically you have to divide your data into train and test, and you have to build the model and training some set of data that is called as training data. uh, for example, 70% data you are training the model, and rest 30% of data you are evaluating the model. Then based upon those you have to finalize which model is good for me. So out I build 3 to 4 models, I finalized third model is the best for me. But that is best out of those 4 models. Now once I got selected the third model is best for me, I will try to maximize the output of the model to the maximum level. So that is called as parameter tuning or hyperparameter tuning. So here I will try to change the values of the parameter related to that particular model. For example, here is the third model. So in that place I will try to fine tune those parameters value, so that I will get the maximum result, or the very high accurate result from that model. So that is called as hyperparameter tuning. Next is model deployment. So now your model is built, model is ready. So next what? Next you have to build, next you have to deploy the model, right? Until unless you are not deploying the model, you are not going to get how you will use that in real time. Because right, not it's not only about building the model and leave it. We have to uh, put that model in real time, and we have to uh, do the prediction in for our use cases, right? So that is called deployment. Here we will use uh, cloud platforms, or there is various kind of APIs we have to use here. So all those we will see in the next future how to do, next slides how to do that. So once you deploy the model, next is monitoring and retraining. Okay, monitoring means you will, once you deploy the model, right? It's not a program that whatever the input will come, output will be always good. It's not like that. You build the model on certain kind of data, but when you do the predictions, the data might be vary. The new data on which you do the prediction might come as some changed data, right? So there you have to monitor your model, how the model is performing on the new or real time data you are getting. And then based upon that you have to see whether your model is performing bad or good. If it is performing bad, so based upon certain statistics and some graph and summary, you have to decide whether I need to retrain it on that model or not. So all we'll see how do those retrain and not. So this cycle is not always linear. Okay, sometimes you have to look back and forth between the steps to see, because that is what I call a retraining process. So this is a typical roadmap for solving a data science problem. Okay, so now you know who is a data scientist, what data scientists do, and you saw uh, basically what a data science project life cycle is. Okay, so next we will be moving to our main step, that is roadmap of a to become a data scientist. It's 2025. So here there are a couple of things. First we'll see what are the things required to be a data scientist. Then we'll see in details in those things what will be the key points to touch upon. Okay, so first of all we'll need is a programming language. So as this is any kind of models are building, so we first we need a programming language. We'll see what kind of programming language we'll need. Then for sure as all of you know, in data science we need maths and statistics, so this is very very important. Okay, you no need to be a mathematician or statistician. Before see before data scientists a few decades back are called as statistician only. So now it's changed data scientist because it involves programming, not only statistics. It involves machine learning models, it involves deep learning models. So for sure you need to know math and statistics, but not in very detail, but you have to know. Okay, next is databases, because you have to work with data, so you have to know databases. We'll see then machine learning and deep learning for sure. And then depending upon which kind of use cases you work, be it computer vision or natural language processing or generative AI, so those will be needed to touch upon. And then finally cloud and APIs to deploy and monitor and retain it. Okay, okay, so first we'll start with the programming language. So in programming language there are two major programming language which will be required here, this that is the Python and R. See, R is very famous among data scientists who are doing a research kind of work. Okay, it's mostly not for data scientists, I will say. Means it can be, but mostly it is for the research kind of groups, or traditional statisticians or mathematicians who do a lot of research, bring out new results. So though they use R, but to solve real world problems, to work in organizations, you need maths. Because there are a lot of advantages to it. It's not only because I'm telling you Python is good, that's or not. Python uh, has lots of libraries, okay, which help which make your life very very easy on performing certain things. In other languages which will take hundreds of line, in Python that may be one line, just call a library and use it. Okay, so that's the advantages of Python. Again we will cover up what all we need to in detail, why Python is needed and what all to cover up in Python uh, in some of our next videos. But for now I'll give a basic overview what we need to cover up in Python. So we need to like basic syntax like data types or conditional blocks, you need to check, and loops. Then Python data structure like list, tuple, dictionary. Then you need to cover up the most important functions and classes, basically loops concept. And then few Python libraries. We'll see in upcoming slides what are the libraries needed for each of the steps. For example, Pandas, NumPy, SciPy, Scikit-learn, like and also like pursuing to cover up error and file handling, because those are needed to build a good script or a good Python program for that. Okay, so next is our main concept, that is math and statistics. So this area is mostly divided into three parts. Okay, one is linear algebra, another is calculus, and statistics of course. In linear algebra it mostly consists of vectors, matrix, in matrix multiplication, eigenvalues, dimension, uh, eigenvectors. So those are kind of things we need to learn from linear algebra. These will be mostly helpful in deep learning kind of models where we'll be involving some neural networks. We'll see what are those things in upcoming slides. Okay, next is calculus. You just know the basics. See, again in maths, algebra, calculus, you don't need to go and do the uh, 12th or 10th those things and solve problems. No, you just need to know the concept, what are those, and how those perform, and how we can apply those in our things. That is the most important, how we can apply those concepts, for example calculus, partial differentiation, okay, or integration. So how you can those use those things in our data science. It's not like we're solving any differential equation here, no. We are going to apply those concepts in our with respect to our convenience, okay. Then most important, statistics. We'll see. So what happen in statistics is, statistics is mostly two, is of two types, okay. One is descriptive statistics, another is inferential statistics. Okay, so descriptive statistics and inferential statistics, right? So descriptive statistics means, because you know there are lots of data here, so you cannot uh, go through each of the data point and understand what are those data. Okay, so in that you will use some kind of central tendency, or some kind of measures which will help you understand what the data are, okay. So for example, min minute mode, right? It will describe what the data is, okay. But it is, you can think this is kind of a representation or a representative of all those data points which you are going to work. So instead of understanding each the data point one by one, you need to get those central tendency measures, and you need to have to draw the conclusion from that. But what is inferential then? But inferential is, uh, you are not going to use all the data, you are going to use a sample of data, okay. So suppose you have thousands of data, I am going to take a set of points of those data which are represented, some of the data representing each of the data points, okay. So so that's the basic difference between descriptive and inferential, okay. So in the statistics there are a lot of concepts, okay guys. I will list out all those concepts one by one, what we need to cover up, and we'll see in upcoming videos in detailed analysis, in detail we'll understand what are those concepts, and we'll see some problem statement on those, and we'll see in details, okay. So for now, so these are the points. First we'll go to basic statistics. Again, these are including both the descriptive and inferential. So for example, population, sample, variable, extreme parameter, random variable, mean, median, mode, standard variation, variance. So these are all basic statistics. Again, there will be distribution, normal distribution, Gaussian distribution, binomial. There are lots of other distribution as well. I have noted down few of here, okay. So we will see what are those distributions are in upcoming videos. We'll cover up all those in details. So these are some kind of basic statistics we need to cover up. Next is advanced statistics. Means it will kind of little bit of, first we have to cover up those topics, then we have to come here. So here mainly come up hypothesis testing, confidence interval, p values, then different kind of tests like z test, t test, ANOVA, chi-square test, and central limit theorem, covariance, correlation, different kind of transformation like box cost, different plots like QQ and IQR, then quantile, quartiles, percentile, then we are of course we'll see the probability. In probability mostly we'll focus on conditional and adjoint probability and including Bayes theorem. Uh, so these are some of the advanced statistics concept we'll cover up. Okay, so next is our core database, because as we're working on the database, so what are the databases will be needed to become a data scientist? So basically you need, uh, you work with any data, okay, you just need mostly two kind of databases. One is RDBMS, or which is kind of SQL type, another is no SQL type, okay. So you have to at least learn one from the SQL and one from the no SQL. If you're learning more, that's very good, but at least one from SQL and no SQL is good to start with, to your journey, okay. So these are few of the databases I have listed out, and you can choose any of them to start with. For example, MongoDB or MySQL or SQLite or PostgreSQL. These are all good databases used in many industries. Okay. So next we'll see machine learning. In machine learning, what we'll cover first? See, machine learning mostly is of two types: supervised and unsupervised machine learning. Supervised machine learning means which works on labeled data, where you have some input, you have some output, and for some new input, you have to predict the output. That is in simple language is supervised machine learning. So there are a lot of algorithms in that. we'll start with our hello world of machine learning, that is linear and logistic regression. Okay. And then we'll cover decision tree, then decision related algorithms like random forest, ada boost, gradient boosting, XGBoost, then some other algorithm like SVM, knn, naive, those things we'll cover up. Next, unsupervised machine learning. Okay, so in unsupervised machine learning is what, you have unlabeled data there. Unlabeled data means those data, there are only inputs, only input columns, there are no output columns. Okay, and you have to find any hidden patterns are there using the machine learning models. So these are mostly called as the clustering kind of models, for example customer segmentation, okay, or anomaly detection. So these are kind of use cases you will do in unsupervised machine learning. It's kind of finding hidden patterns without having the output or label data. So it includes algorithm like k-means, that is again hello world of unsupervised machine learning, and then db scan, hierarchical clustering, then we'll see some dimensional reduction like pca, and some anomaly detection algorithm like isolation forest. Those are also common unsupervised machine learning. Of course, we need few of the Python libraries to do operations on this. For example, scikit-learn is the most famous library for doing the machine learning problems, and some specialized library, for example, XGBoost, that has its own library. It's not common as scikit-learn. So we'll see all those. Okay, then we'll cover up deep learning. In deep learning, first we'll start with artificial neural network, because again, deep learning is not a one topic or simple topic, right? uh, uh, See, deep learning, what happened in machine learning is, that is the traditional ML, what I call as a traditional data science problem, where engineer features manually. Machine learning is basically where you are trying to build any equations, okay, mathematical equations using the data you have, and for a new input you will try to put those input in that equation, and you will try to get the output. For example, one simple example, it's not called any machine learning algorithm. One simple example is uh, x1 2x1 plus 3x2 is equal to y. Okay, y is equal to x1 plus 3x2. So x1 x2 are the input. This is a mathematical equations. This is kind of a machine learning, where you have some x1, have some x2. For new input you are getting, you will have x1 x2, you will put there and you get the y. But here, what we are doing, building that equation 2x1 plus 3x2 is equal to y, that is machine learning. Okay, but in deep learning what happens, it not kind of building any equations. Of course it involves equations, it not like not involve equations, but it's basically it try to mimics human brain. Okay, in human brain we have neurons, right? That's how our brain works, based upon the neurons we have in brain. So from that it derives neural network. So it try to mimic how human brain works, how human brain learns the patterns and things. So like that, deep learning has been made, where the networks learn features automatically. Okay, so these are mostly used for input like images, text, speech, and very different complex patterns, where machine learning are mostly used for tabular kind of data, like excel or csv kind of data. I mean, having rows and columns, having some input columns and output columns, even only input columns. Okay, that's the basic difference between machine and deep learning. So in artificial neural network, first we'll see what is a neural network. Then we'll see perceptron, layers, and some of the concept needed while building the neural networks, like activation function, loss function, weight initializations. Okay, these are some of the concept needed. Then to build a good model, you need optimizers, gradient descent. For example, gradient descent, SGD, ADAGRAD, ADAM, RMS. Then to improvise those, we need regularization, the neural network. So this is what you call the base of all the deep learning models, what you saw today, or you saw in past. So these are the basic for all. And here we'll have some good libraries to use. Again, there are few like pytorch, keras, tensorflow. Keras, tensorflow are good to start with, but pytorch are mostly used in the industry. Still TensorFlow is used in an industry, but Python is mostly acceptable. But TensorFlow is good to start with. Okay, if a direct start, you can start with any of the library, but if you're having the TensorFlow class, you can able to understand the concept very good in a very good manner. So next we'll be covering up computer vision, which is the call as mostly convolutional neural network. So previously we have see artificial neural network. Here we see convolutional neural network, which is mostly used for computer visions, which has input as images or videos. So here you will see concept like pooling, kernels, LexNet, AlexNet, BGNet, Inception, Visual Network, then mobile net, and the most infamous algorithm in computer vision is yellow. Okay, and then some of the libraries like OpenCV, SimpleCV, Yellow, and CUDA is kind of help us in building models in a very efficient manners used in this kind of thing. Then we'll cover up our most talkable topics in NLP or natural language processing. Here we'll see topics like RNN, LSTM, GRU. RNN basically means recurrent neural network. So you see first you saw artificial neural network, which is the base. Okay, then you come to convolutional neural network, which is again based upon artificial neural network but specialized for images and videos kind of input. Then you came to NLP, which is the recurrent neural network, which is mostly specialized for text, but nowadays it started going in other domains as well. Okay, so in that we say LSTM, GRU, some of the embedding methods like TF-IDF, there are traditional backup parts, Ngram, and some new like what to bake, Glove, Elmo. Then our the famous library attention mechanism, encode decoder, and based upon the transformers, some of the best model in that base model in that like bot, GPT, T5, Cloud A, then transfer learning. How you can build different models from the same model using the same version of model. You can use create new models. Okay, instead of building everything from scratch. So this is all about NLP. So again here you have some good libraries like starting with Space NLTK, Allen NLP, GenSim, Stanford NLP, then our most useful Hugging Face. So these are some of the kind of NLP libraries. Then we'll come to our generative AI. Here you have attention mechanism. Here base is attention mechanism mostly. Then which is leads to transformers and some uh, talkable topics like large language models, visual transformers, GAN, embedding models, multimodals, diffusion models, and then ways to implement them like prompt engineering, RAG AI, fine tuning LLM, then vector database, agentic AI, and transfer learning. Okay, then we'll come to our some of the libraries like LangChain, QI, Hugging Face, and some of the model library like OpenAI, Cloud A kind of models. Those are usable models. LangChain, QI are kind of frameworks we can say to build any RAG application or agentic application. Where Hugging Face is the model library where you have all kind of open source model. OpenAI has its own closed source models where other libraries are there like Cloud A, Mistral. They have their own model. Gemini, they have their own models, or Llama. Okay, so they have their own library and own models. So this is all about generative AI. Again we'll see all those things in detail, roadmap to NLP and roadmap to Gen AI, all those things in details, because we cannot cover everything here. It will be very long videos. Okay, so next is our cloud platform and APIs. So here basically we'll see different cloud platforms like AWS, Azure, or GCP, which you can use to deploy your model. Lot of services in them. For example, SageMaker, they have Azure ML Studio, Functions, Lambda, VM, EC2. They have inbuilt databases like Dynamo, Cosmos, RDS kind of there. Bedrock kind of models are coming up there. Okay, so these will be used for deploying, monitoring, and even you can build the models in yourself cloud platforms as well. So at least one of the cloud platforms you must need to know. Okay, if not all. Then to build the application, right, to communicate between the front end and back end, because what we are building will be in the back end of the of a software of the application, right? So how we will send those into front end or to the UI. right? Then you need APIs. So basically the base Python API framework is a Flask, which is very easy to use and easy to learn as well. You can even learn in few days Flask, how to build a Flask application. But if you want to build a good application or advanced application, then you can use either Fast API or Django. See, Django, I mean, is a very heavy framework which is mostly used by Python developers who build applications. But as a data scientist, it is good to start with Flask, then go to Fast API. And if you have that much of necessity to learn Django, you can learn it. Okay, so otherwise, Flask and Fast API are mostly can do all the jobs in data science point of view. Okay, so see, there are a lot of other concepts to cover up to become, because now what the data scientist was 5-10 years ago and now is very different. Now also you need to know MLOps, that is very uh, uh, upcoming. It's already not upcoming. Then you need to know microservices. So these are few of the advanced things or extra things. But what we cover today is the must things you should know. Okay, but these are the extra things because there are separate job profile for that also, like MLOps engineer, AI engineers, data engineers, okay, or DevOps, or mostly microservices who handles that, then doing the API testing and all. Okay, so those will come there. And for sure you need to know any of the project where you can save your code or save your project, or you can build profile to get to the job, like GitHub or Bitbucket kind of thing. Mostly GitHub is very much friendly, user friendly, and you can use in initial time or time. Okay, so these are things we'll see next, how to cover up MLOps, microservices, data engineering, uh, AI engineering. Even nowadays LLM ops comes as well. Okay, we'll see all those things. So that's wrap up the complete roadmap to becoming a data scientist in 25. I hope this gives you a clear direction and confidence to start or level up a journey in this field. Yeah, wow, I'm just getting started. In the upcoming videos, I'll be diving deeper into each major topic, including Python essentials, statistics for data science, machine learning, deep dive, NLP, Gen AI, and even how to deploy your models in MLOps. I'll be releasing focused video every week. Make sure to subscribe to Screen Neurons and hit the bell icon to stay updated. Thanks for watching, and I'll see you in the next one.